consider the set V over my screen, for which of the following choices the set V becomes the two-dimensional subspace of RQ. Now subspace of RQ, subspace of RQ over R, we know that trivial line passing through, single line passing through origin, plane passing through origin, plane passing through origin, and subspace R cube itself. So there are 4 subspace of R cube. To become a subspace, it is necessary 0 element must be there. So when 0 element will be there, because this is a subspace, we want to make it subspace of R cube. So take 0 elements in R cube, means x, value of x, value of y, value of z. If we put 0 together, then gamma equals to 0. Means gamma must be 0. Option B discard here, because gamma is not 0. And to make two-dimensional subspace, what does it mean? Dimension of V can be written as R cube, means dimension of R cube is 3, minus number of Li constraint. Here constraint, Li constraint is 1. So 3 minus 1. Dimension of V, if it is not given to you, problem can be asked what is the possible dimension. So dimension will be 2. Now on further investigation, alpha x plus beta y plus z equals to gamma, because gamma must be 0. We have this condition, and x, y, z, these are choices from R cube, and make two-dimensional, one must be free variable. Let's say z is free variable. Z is free variable. So you can write z equals to minus of alpha x minus of beta y. Then x and y are independent choices. It means if you set any value, any arbitrary value of x and y and respective alpha beta, then you can obtain easily z. The only key concept to solve this problem is to become a subspace, it must pass through origin. That's why gamma should be 0, and there is no other restriction on alpha beta. There is no other restriction alpha beta, it may be any value. So key is option A, C and D.